Lorraine, late 1944. The mine detector said nothing. Not a weak signal. Not a broken signal. Nothing. An American combat engineer lay flat in the frozen mud with his rifle behind him, his helmet tilted low, and a thin steel probe in his right hand. He did not push the probe straight down. That could kill him. He slid it into the earth at a shallow angle, 30 degrees, sometimes less, a few inches forward, then another few inches. No beep, no warning, no electronics telling him he was alive, just mud, breath, cold fingers, and the tiny feel of resistance beneath the ground. Then the probe touched something that should not have been there. Not stone, not root, a manufactured edge. The mine was almost invisible to every instrument the Allies carried. Its casing was pressed pulp, cardboard, tar, and non-metallic filler. Its pressure plate was molded fiber. Its fittings were glass or ceramic. The only metal was buried so deep inside the detonator that a standard detector could pass over it and hear nothing. That was the point. Germany had built a mine designed to disappear from machines, but the American engineer was not asking the machine anymore. He was asking the ground. In that field, men like him found mine after mine after mine, not because the instruments improved, because the method had. And somewhere on the German side, a pioneer who had spent days planting those same mines had to face a conclusion his training had never prepared him for. He had helped build the invisible weapon, and the enemy was finding it anyway. This is the story of how Germany chased silence underground, and how the Allies learned to listen with hands, eyes, paper reports, and men crawling through mud. The contest began long before the rain. It began in the desert, where mines were cheap, ground was open, and time was the most valuable thing an army could lose. By 1942, Erwin Rommel did not have enough fuel. He did not have enough tanks. He did not have enough reliable supply lines across the Mediterranean. What he did have was mines, hundreds of thousands of them. At El Alamein, German engineers turned the desert into what their own side called the Devil's Garden. 2 belts of mines, miles deep, layered across the front like a buried wall. Anti-tank mines for vehicles, bounding mines for the engineers, anti-handling devices for anyone who tried to lift the wrong object, scrap metal scattered across the sand to make every detector nervous. A minefield did not need to defeat an army by itself. It only needed to slow it, break its rhythm, and force men to kneel under fire. That was Rommel's calculation. A mine cost little. A minute on a battlefield cost everything. The British method at the beginning was brutally simple. Walk, probe, mark, repeat. It worked. But it was too slow for a battle that would not wait. A man with a bayonet or pointed stick could clear a patch of ground, but a desert belt 5 miles deep did not care about patience. The Allies needed a machine that could turn buried danger into sound. They found it because of a tragedy on a Scottish beach. Joseph Kosaski was a Polish electrical engineer in exile. Before the war, he had studied telecommunications in Warsaw. After Poland fell, he escaped German captivity, crossed through Hungary, and reached Britain. There, like many exiled specialists, he was underused. He trained soldiers in signals work while the war moved around him. Then, in June 1941, a Polish patrol walked onto a minefield near Arbroath in Scotland. The mines had been laid by the British as coastal defense. The Polish unit had not been properly warned. 12 men died on ground they believed was safe. Kosaski had already worked on a mine detection idea before the war interrupted it. After Arbroath, it stopped being an idea. It became a debt. In a few months, working with scavenged radio parts and practical electrical knowledge, he built a detector light enough for soldiers to carry and simple enough to manufacture in wartime. A search coil at the end of a pole, a signal in headphones, a backpack battery and amplifier, a tone that changed when buried metal disturbed the electromagnetic field. The British tested competing designs by hiding small coins in a lawn. Kosaki's device found them. Fast. All of them. The detector went to war under names that often hid his identity, because German occupation of Poland made public credit dangerous for his family. The men who carried the device often did not know the real name of the man who built it. But at El Alamein, hundreds of those detectors helped British engineers cut paths through the Devil's Garden. The machine worked, the army advanced, and German intelligence drew a lesson that was logical, technical, and dangerously incomplete. If Allied engineers were finding mines because of metal detectors, then Germany needed mines with less metal. That was true, but it was not the whole truth. The detector was useful. It was not the system. That difference would decide the rest of the contest. Because even in North Africa, detectors lied. They gave false signals over scrap. They struggled in contaminated ground. They became unreliable when shell fragments filled the soil. They could turn a field into a storm of noises where every sound might be a mine and every silence might be worse. American engineers arriving in the theater learned the hard way that a detector was a shortcut, not a guarantee. When the instruments stopped being trustworthy, they did not stand up and call the field clear. They went down. Hands, knees, probe. Every suspicious patch of earth had to answer the older question: is something solid buried here? Germany spent the next 3 years trying to defeat the detector. The Allies spent those same years making sure defeat of the detector did not defeat the engineer. That was the fork in the road. One side refined the object. The other refined the institution. After every minefield, reports moved backward through the army. What kind of mine was found? How deep it was? What soil hid it? What pattern the enemy used? What visual signs appeared after rain? What the detector missed? What killed the men who trusted it too much? That knowledge did not stay in one exhausted platoon. It became training. It became doctrine. It became new manuals. It crossed from Tunisia to Italy, from Italy to England, from England to France. A dead man in one field could not be saved, but the mistake that killed him could be written down before it killed the next one. Germany's answer arrived in wood. The Schumann 42 was not elegant in the way a laboratory instrument is elegant. It was elegant in the way a trap is elegant. A small wooden box, a hinged lid, a block of explosive, a simple detonator. Pressure on the lid released a striker. That was all. The mine was cheap, fast to build, easy to hide, and almost invisible to the electronics Allied engineers trusted against steel-cased mines. Its purpose was not to destroy a tank. It was to take a foot. That distinction mattered. A dead soldier removes one man from the line. A wounded soldier can pull 3 or 4 men into the work of carrying, treating, evacuating, and remembering him. The shoe mine was a weapon against movement, manpower, and nerve. In Italy, Allied engineers met it in the mud and stone around places like Cassino. Their detectors swept ground that looked safe. Then men stepped forward, and the earth answered. Casualty reports talked what the machine had not. Wooden mines left different traces. A slight rectangle after rainfall. A disturbed patch in clay. A change in vegetation. A place where the soil had settled too neatly or not neatly enough. The lesson was not romantic. It was not instinct. It was repeated failure turned into procedure. Look first, sweep if you can. Distrust the sweep when the ground tells a different story. Probe at an angle. Never stab straight down. Mark what you find. Teach the next unit. Germany pushed farther. If wood could hide from a detector, glass could hide even better. The Glassman 43 used a glass body, a glass pressure plate, and in later forms, chemical firing parts that could reduce the metal content to almost nothing. It also served German industry. By 1944, steel was needed everywhere. Tanks, guns, vehicles, aircraft, spare parts. A mine that consumed almost no metal was a tactical countermeasure and a resource solution at the same time. Millions were made. Many were never planted before the war ended. But the ones that were planted created a kind of wound that was especially cruel. Glass fragments did not behave like metal fragments. Surgeons could not find them as easily. Buried glass did not rust away. It sat in the ground with patient indifference. From the German side, the logic seemed clean. Allied detectors respond to metal. Remove the metal. Bury false metal nearby. Make the ground noisy where it should be silent, and silent where it should be deadly. That should have worked. Against a machine, it did. Against a trained system, it was less certain. Because deliberately scattered scrap metal also told an experienced engineer something else. Someone wanted this field to confuse detectors, and if someone wanted the detector confused, the field deserved more suspicion, not less. The deception became a signal. A man lying flat in the mud could see what a standing man missed. Soil color, broken crust, a line that did not belong, grass that failed to grow over a newly buried object, a faint circular settling over glass, a shallow rectangular rise over wood. None of this looked like doctrine at first. It looked like men surviving long enough to notice small things. Then the small things became reports. The reports became drills. The drills became habit. And habit, in a minefield, was the difference between crawling and being carried. There was also a problem Germany had created for itself. A mine invisible to Allied detectors is also invisible to the Germans who buried it. The army that plants a field may need to cross that same field later in darkness. Rain, shell fire, retreat, or counterattack. Maps get lost. Markers get blown away. A safe lane becomes unsafe when artillery rearranges the ground. So Germany built a secret answer into one of its most deceptive mines. The top mine was a pot-shaped anti-tank mine made largely from non-metallic materials. Pressed pulp, cardboard, tar, glass, ceramic, and explosive. To Allied electronics, it could look like nothing. But German engineers coated it with a special radioactive marker known as Tarnsand. German pioneer units could use detectors with Geiger counter components to find their own mines by radiation signature. It was a clever solution to a real problem. It was also aimed at a fight the Americans were no longer fighting in the same way. The Germans were hiding the mine from electromagnetic detection. The Americans were often not relying on electromagnetic detection. They were already in the mud with probes. That is why the secret had such a bitter shape. Germany built a hidden code so its own men could find an invisible mine. The enemy found it by touching the earth. A comedian would later explain the method more clearly than most technical summaries. Mel Brooks, before he became Mel Brooks, served as a combat engineer. He described probing the ground with a bayonet and listening for the tiny sound that meant danger was below. Tink, tink, tink. It sounds crude until you understand what it replaced. Not science. False confidence. The probe did not care what the mine was made of. Wood, glass, pressed fiber, bakelite, paper, ceramic. If the object was solid and buried where it should not be, the probe could find it. Slowly, dangerously, imperfectly. But it asked the one question German material science could not evade. Is something there? Normandy made the same lesson larger. Before dawn on June 6, 1944, amphibious engineers approached beaches that German planners had spent years preparing. Rommel wanted a coastline so saturated with mines that no invasion could survive its first movement inland. He did not get everything he wanted, but he got enough to make the beaches a machine for delay. Teller mines on obstacles, mines above the tide line, mines lashed to stakes, mines placed where vehicles would need to move, mines placed where men would try to clear the way. The engineers had rehearsed for months in England. Cut obstacles, open lanes, build exits, clear mines, in that order, under fire, before later waves arrived. The work was not abstract. It had names. One engineer remembered a teammate known as Ham, a former baseball player whose life had once been organized around his legs. In the surf, he stepped on a mine. He was evacuated. Both legs were taken. When he understood what had happened, he asked what a baseball player was supposed to do without legs. He did not live through the day. A road later built across the beachhead carried his name. That detail matters because doctrine can sound bloodless after the fact. It was not. Every improved method was purchased by men who found the flaw with their bodies. By the time Allied armies moved across France and toward Germany, mine warfare had become a layered contest. Electronic sweep when useful, visual reading at ground level, hand probing where the machine failed, unit reports after each field, manual updates, training cycles, specialized engineer battalions, dogs tested where scent might help, flail tanks used where terrain allowed, and always, beneath the technology, the man with the probe. The army did not abandon devices. It stopped worshiping them. That is why late 1944 looks so strange from the German side. In one Lorraine field, American engineers faced ground that gave no useful electronic warning. Conventional mine detectors found nothing. Experimental detectors found nothing. By instrument logic, the field should have been safe, or at least unreadable. The engineers did not accept that answer. They had been trained to distrust clean readings when the earth showed disturbance. So they lowered themselves into the mud and began the slow work. Probe, mark, lift, move. They removed thousands of mines from that single area. Non-metallic mines, minimum metal mines, mines that had done exactly what their designers promised. They had defeated the instrument. They had not defeated the procedure. To the German pioneer watching the result, the wrong thing had failed, not the mine, the theory. The mine had become almost silent to machines, but the battlefield had become audible to an institution that knew silence itself could be suspicious. That is the part German design offices appear to have misunderstood. They kept asking how to make the object harder for a detector to hear. The Allies kept asking what a soldier should do when hearing failed. Those are different questions. One produces a better mine. The other produces a harder enemy. By 1945, German mines had become an industrial world of their own. Steel teller mines, bounding S mines, wooden shoe mines, glass mines, pot mines, improvised charges made from whatever factory still had available. The numbers were staggering, because mines made sense for a Germany running out of everything else. A mine could hold a road after the men had withdrawn. It could kill a tank long after the gun crew was gone. It could make a field dangerous without feeding, fueling, or resting. And it could impose fear at a discount. The Allied cost was real. Mines destroyed vehicles, slowed advances, took legs, killed engineers, forced commanders to spend time they did not have. But the strategic contest underneath had shifted. Germany was still innovating in material. America and Britain were innovating in transmission. How fast can one field's failure become another unit's training? How quickly can a casualty report become a safer hand movement? How many soldiers can be taught not just to use a tool, but to understand when the tool is lying? That was the hidden weapon on the Allied side. Not Kosaki's detector by itself, though it mattered enormously. Not the probe by itself, though it saved lives. Not the dog teams, not the flails, not the manuals. The weapon was the loop. Failure became evidence. Evidence became doctrine. Doctrine became rehearsal. Rehearsal became reflex. Reflex kept men alive long enough to create the next report. Germany could redesign a mine. The Allies could redesign the behavior of thousands of engineers. And behavior, once trained deeply enough, is difficult to fool with a change in material. That is why the story does not end with the perfect detector. It ends with the imperfect man in the mud, cold, terrified, slow. No heroic music, no clean machine solving the ground, no instant flash of genius. Just a soldier who had been taught that silence was not safety. A soldier who knew to look for the disturbed skin of the earth. A soldier who understood that the right angle of a steel probe mattered more than the pride of an electronic instrument. A soldier who kept moving forward by inches while an entire engineering program failed to understand what he represented. Joseph Kosatsky's detector remained useful for decades because the idea was sound. German non-metallic mines were dangerous because the countermeasure was real. The shoe mine, the glass mine, and the Topf mine were not failures of engineering. They were successes, pointed at an enemy that had already adapted beyond the narrow target. The German pioneer in Lorraine was not wrong to believe the mine was invisible. It was invisible to the thing he thought mattered most. But the Allies had stopped making one thing matter most. That was the difference. They had built redundancy out of suffering. They had turned reports into training. They had taught men to read mud, broken grass, disturbed clay, and the tiny resistance beneath a probe. Germany had built silence. The Allies had taught men how to listen.